Hello, this is Professor Brown-Cedarberg, and we're going to look at repetition in Java. We remember Jacopini and Bohm put forth a paradigm that all programming can be accomplished with sequence, selection, and repetition. We're going to look at repetition or loops today. Now in Java, repetition is accomplished through the while loop, the do-while loop, and the for loop. Now when we're working with loops, we truly want to control them, and because loops will repeat while a condition is true. So we want to control our repetition of our loops. We know that a loop will repeat as long as the condition is true. Now, two of the common ways to control loops are sentinel values and counters. Now, a sentinel is a value, a special value, that can't be mistaken as part of the data that we want to process. It's very often appended to a data set to signal the end of the data, and it signals the end of the loop, and when it's entered, we terminate the loop. A common sentinel value would be, well, let's say we're putting together a program that will find the average of a number of quizzes, and we don't know how many quizzes we're going to enter, and so we just ask the user to enter quiz after quiz after quiz grade. And we'll write our program so that if the user enters in a negative number, that'll signal the end of the grades. Hopefully you can't get a negative as a quiz grade. So that's an example of a sentinel value, a value that's clearly not in the data set. Once entered, we end the loop. Another control for loops is a counter. Right? With a counter, we have to initialize a control variable with a starting value. I test that control value to a value. Right? And then I terminate the loop when that test is failed. So I have a control variable. I test it to a value. When that test is failed, I'm out of the loop. As long as that test of value is to true, I stay inside the loop. Now, with counter control, I have to have something inside the loop that will update that value so that eventually, it'll update what I'm testing so that eventually I'll have that test failed. Otherwise, I'm going to have an infinite loop. So with counter control, I have a variable. I test that variable to a value. I terminate the loop when the test is failed, and I have to have an update of that control variable so that eventually the test will be returned back false. All right, now controlling my loops, I have a couple of executable lines of code that I can use to help me along with it, and that's break and continue. These are commands, just break, semicolon, continued, semicolon. Now with a break, what happens is I exit the loop. Programming within that loop, it just control goes to the next line that follows the loop. So I just absolutely end the loop. That's what the break statement does. With the continue statement, I end that iteration of the loop. I don't process any more of the lines within the loop. I just go back up to the top. So break exits me out of the loop totally. Continue breaks me out of that iteration of the loop, takes me back up to the top. All right, now with loops, we have to talk about variables. Variables that are declared inside a loop are local to that loop. That's their scope. Variables that are declared outside a loop can be used inside the loop, as long as they've been declared before the loop. Right? So a variable declared inside a loop comes to life on declaration, dies at the end of that loop. Variables declared outside a loop, before the loop, are accessible to that loop. Okay? And they're accessible afterwards too. So the challenges of loops are this. First, the construction of that condition, that test that we'll be using over and over and over again. The second is that we don't have infinite loops, that eventually our test will fail and we'll be out of the loop. The last is being off by one, having a loop execute one more or one less than the intended number of times. These are the challenges you have with loops. Okay, so let's look at our first loop. It's a while loop. A while loop is a pretest. I test before I go into the loop. I enter the loop if a condition is true. I repeat the loop as long as that condition is true. Now with this, remember, the loop may never be entered. If on first test I have failure, I won't go into the loop. So it's a pretest. That's what a while loop is. My condition has to somehow become false within the loop. If I don't, I'll have an infinite loop. So a while loop is a pretest. I enter the loop if the condition is true. I repeat as long as the condition is true. I might not enter the loop, and my condition has to become false somehow so that I can exit the loop. So here's the format of a while loop. It's while and then the condition in parentheses. Notice there's no semicolon at the end of that line. The body of my loop is within curly brackets. Those executable lines of code, the body of the loop, will be executed if the condition evaluates to true. Here's a flowchart of the while loop. You'll see that I test my condition. If it's true, I take the action, come back up, test again. If the condition evaluates to false, we're out. Here's an example of a while loop. I've got an int a, I give it a value of 0. As long as a is less than 10, I'll go into the body of my loop, and in this body, I will print out the value of a, go to the next line, and then increase a. So this while loop will execute 10 times. It'll print out the values 0 through 9 to the screen. Here's a do-while loop. Now a do-while loop is a post-test. I enter the loop if the condition is true or false. There's no test of the condition before my initial entry into the loop. The loop will always be entered. I'll repeat the loop as long as the condition is true. The condition has to become false sometime, somehow, within the loop so that I can exit it. So a do-while loop is a post-test. A do-while loop is always executed at least once. Here's the format of a do-while loop. Notice they have the do, there's no semicolon there, the body of the loop, and then while. Following the while is the condition, that's within parentheses, and then a semicolon. This is the format of a do-while loop. I've got do, body of the loop, while, my condition, and then that semicolon. Here's a flowchart of the do-while loop. You see that I take the action, then do the test. If the test is true, I come back up, do the action again. I then test again. If it's false, I'm out. So the action is always taken at least once. Here's an example of a do-while loop. I've got a value a, type int, give it a value of 0. I have my do, then my body of my loop, which is to print the value of a to the screen. I plus a. Here's my test while a is less than 10. So this will print to the screen 0 through 9. I'll go into this loop before I take any test. This is a do-while loop, so it's a post-test. If I had given a value of 33, I would have printed to the screen 33 and then been out. A do-while loop is always executed at least once. Our last loop is the for loop. For loop is a pretest. It has an initialization statement that's executed once. I enter the loop if the condition is true. I have a condition. I repeat the loop while a condition is true. The loop might never be entered, remember, because this is a pretest. The condition must become false somehow, and it's going to become false in the for loop through an update statement. So here's the format of a for loop. I've got the keyword for, and then I have my initialization statement. That happens only once. That executes only once. Notice that there's a semicolon after it. I have then the condition, a semicolon, and the update statement, and then the body of my loop. Here's a flowchart of the for loop. I have my initialization. That happens once. I then do my test. If my test of my condition of value is to true, I take an action and I update. That update's done every time I iterate through the loop. My update's done. I come back, I do my test again. If it's my test of value is to true, I go into the loop and execute again. If false, I'm out. Here's an example of a for loop. I've got an int I give it a value of 0. That is only executed once. That int I equals 0. That happens once. Then I have my test is I less than 10, and then my update plus I. So here's my declaration and initialization of my int I, my test, and my update. And this for loop prints to the screen the value of I. So this would print out 0 through 9. Now, I can have multiple initializations. I can remember that my initialization executes only once. I can have multiple initializations, but all of them must be of the same type. And I'm going to separate them by comments. Here's an example of multiple initializations. I've got my for loop, and it's for int I equals 0, and then j equals 2. I've got my same test, I less than 10, and plus I. Here I'll print to the screen I times j. So my multiple initializations, same type, separated by commas. Now, I update my for loop each time I go through the loop. An update is executed each iteration of the loop. I can have multiple updates. I separate them by commas. So here's multiple updates. Here I've got my for statement, and I've got int I equals 0 and j equals 2. We looked at that. Here's my test I less than 10, and here's my multiple updates, plus plus I and plus plus j. Notice that they are separated by a comma. And in this example, I'm just printing the screen the value of I times j. Now, when I'm working with for loops, my declaration of initial values can be made in or before the loop. Right? I can declare and initialize initial values before a loop. In, that is, if my initial declarations and my assignment of initial values is done inside the loop, that variable is local to the loop. If my declaration and initialization or my declaration alone is done before the loop, my variable is not local to the loop. So let's look at this. Here I've declared an int called I. I did that outside the for loop. Inside the for loop, I give an initial value to I. I give it a value of 0. And then I go through my test I less than 10 plus plus I. I has been declared outside the loop, so its scope is not local to the loop. I will be available after this loop is all done because it's been declared outside the loop. Here I see that I've declared I outside the loop and given an initial value. With that, I don't even have to declare and give a value inside the for loop. As you'll see here, I just have that semicolon as the very first character within the test. And this is absolutely valid. So here I've both declared and given an initial value to my int I, and then used it in my for loop. And we typically use I as the name of the counter for loops. It's just convention. So with the for loop, I can have off by 1 errors very easily. So here's 3 for loops. You notice the first one is for int I equals 0 as long as I is less than 10, and then plus plus I. Second, int I is equal to 1, I less than or equal to 10, plus plus I. The third, for int I equal 10, I greater than 0, minus minus I. And then for int I equals 10, I greater than or equal to 0, minus minus I. So the first loop for int I equals 0, I less than 10 plus plus I, that'll execute 10 times. If I have my initial value be 0, and I'm incrementing each time I iterate through the loop, I'll go through that loop the number of times that I am less than. So here I'll go through that loop 10 times. My next, for int I equals 1, I less than or equal to 10, plus plus I, that'll also be executed 10 times. If I set my initial value to 1, and my relationship less than or equal to a value n, let's say, I'll go through that loop n times as long as I'm incrementing that control variable. So my third is int I equals 10 as long as I is greater than 0, minus minus I. That'll execute 10 times. And here I've started at the higher value, that's my initial value, and I'm going through this loop as long as I is greater than 0, and I'm decrementing I. Right? That'll go through 10 times. My last example, int I equals 10 as long as I is greater than or equal to 0, minus minus I, I'll execute that 10 times. Notice that I give I initial value of 10, and my relationship is greater than or equal to. I'll execute that 10 times. So when you're constructing for loops, be very careful of the initial value and then the relationship. That will determine how many times you go through your loop. Now we can nest loops. We can put any number of loops within other loops. We have to be very careful that our loops do not overlap. Each loop is self-contained relative to the scope of variables, the break and continue statements. So let's look at an example of a nested for loop. Here I've got a for int r equals 0, r less than 5 plus plus r. That's my outer loop. My inner loop is for int c equals 0, c less than 4 plus plus c. That inner loop starts with that opening curly bracket, closes with that closing curly bracket, and what it does is it prints a single asterisk to the screen. Now what this example does is prints to the screen a series of asterisks, 5 rows of 4 columns each. I come into the outer for loop, establish r equal to 0, test if r is less than 5. If it is, and it is on first try, I go into my loop body, and the loop body, the outer loop body, is the inner loop, which is for int c equals 0, c less than 4 plus plus c. If C is indeed less than 4, and it is on first entry. We will print out to the screen an asterisk. We'll then go up to the top of the inner loop and increase C, so it now has a value of 1. We'll test C. Is it less than 4? Yes, it is. We'll go into the body of the loop. And so this inner loop will execute 4 times, printing 4 asterisks across the screen. After that inner loop is done, we'll execute the next line, system.out.println, which takes us to the next line. Having done that, we're back up to the top of the outer loop. R, which had an initial value of 0, is now incremented, has a value of 1. We test, is R less than 5? Yes, it is. We go into the loop, the outer loop, which is the inner loop, and we'll reestablish C given a value of 0. We'll test is C less than 4, and we'll go into that inner loop. And so this example will produce for us asterisks, 5 rows, 4 asterisks in each row. Now, I can nest while loops also. This example is a nesting of while loops that accomplishes what we did with the for loop. It's 5 rows of 4 asterisks in each row. So when we look at loops, we remember that we have while loops, do while loops, and for loops. We want to make sure that we control our loops, and we can do that with counter controls, sentinel controls. We know that we can nest our loops to produce very sophisticated programs. Thank you very much.